Hello, and in this video we're going to talk a little bit about graphing functions. So there's a bit of things that we have to look at when it comes to graphing functions. So one of the things of which that we do consider, for example, is looking at the domain, looking at the range, and behavior, x-intercepts, y-intercepts, levels of increasing, decreasing, concavity, and relative extrema, or even absolute extrema for that matter. Now, let's say that we consider the following equation. So let's say that we have y equals to negative 3, not negative 3, but negative x cubed plus 3x plus 2. Now, I know that this is a polynomial, so basically I already know that the domain is from minus infinity to infinity. But furthermore, I look at the end behavior and I can tell that for the end behavior, we have that n is odd, so n is 3, and we have that n is less than 0. So basically that implies that the end behavior looks like this. So that means that the range, well, not necessarily that we know that the range, but essentially, you kind of do this so many times that you already know that the range is from minus infinity to infinity, whereas if this was even, we might not know the range just yet. Okay, now, the other thing of which that we can look at, for example, is the y-intercept. Now, I know that, the y-intercept is basically just at 2, but I don't know about the x-intercepts just yet. Now, we can actually find the x-intercepts respectively as needed, but I don't think that we really need them right now. So, I mean, you can leave this as a question, or if you want to just go back to it later, you can. Now, the next thing that we would need to do is look at the derivative. So y prime equals to negative 3x squared plus 3. Now, that tells us that basically we have that there's a critical point. So we have 0 equals to negative 3c squared plus 3. But that gives you that c is equal to plus or minus 1. Now in that case, we can actually go ahead and figure out the levels of increasing decreasing, because we have that's going to be our critical values. So like we can plug in 0, we can plug in 2, we can plug in negative 2 back into this original equation. Now if we plug in 0, we're going to find that this is going to be positive. But if we plug in, let's see, but if we plug in negative 2, that's going to be, let's see, that's going to be negative because, yeah, negative 2 squared is positive, but times that is negative, so it's going to be bigger than this one. If we plug in 2, basically we have the same thing. We have that it's going to be negative. Now, that means that the graph of the equation is basically decreasing, increasing, and then decreasing, which means that technically now we know what we have. We have that there's a min, and we have that there's a max. So if we plug in these values back into the original equation, we have that if we plug in negative 1, you actually, interestingly enough, you're actually going to get that this is going to be 0. Okay, so we have at negative 1, it's going to be 0. And then we said that this is going to be a minimum. So we have that that's going to be a minimum. Now, technically, that's relative because you have that the range is minus infinity to infinity. Then you have that if you plug in 1, well, you're going to get that that's going to be 4. So that's going to be your other relative max, or relative extrema, which is in this case a max. Okay, now at this point, all that you need to do is just go ahead and find the levels of increasing decreasing. So we have that this is increasing from -1 to 1, and then it's decreasing from minus infinity to -1, union from 1 to infinity. Okay, so notice that this is actually consistent with the end behavior, which that's not a coincidence. If we take the derivative, again, we get -6x, which means that 0 is your point of inflection, because if you set this equal to 0, you just get that x equals to 0. Now, if I plug in values less than 0, such as -1 and 1, well, this is going to be positive, and this is going to be negative. Now, notice that 1 sits over here, so it's minus, so it's a max. -1 sits over here, it's positive, so it's a min. That's no coincidence either. So we have that this is going to be concave up, and that's going to be concave down. So what that means is that we've also figured out the levels of concavity. So we have that that's concave down from 0 to infinity. We have that it's concave up from -infinity to 0. And the point of inflection is 0, comma 2. Now all I need to do is just go ahead and plug this in, or to plot it in the x and y plane. So we're just going to plot this in the x and y plane, where we just graph all of the important points as needed. So we have 0, comma 2, we have -1, comma 0. Okay, so we have 0, comma 2. Let's put it right there. Yeah, 0, comma 2. And then we have 1, comma 4. So that would be right there. And then let's see, we have -1, comma 0. So we'll just put it like right here. Now, interestingly enough, if we graph another point, such as -2 or 2, we find out that 2 is actually going to be like right about here. So it has that it factors as x minus 1 squared. Yeah, because if you go ahead and you factor that equation, you have that it's really x plus 1 to the second power times x minus 2. Wait a second. But it's negative. Yeah, so it's negative. Okay. Now, all that I need to do here is just kind of just use the end behavior. So we have that the end behavior goes like that, but it bounces off of that point, and then it goes like this. Oops. And then it goes like that. Now, this is my rough sketch of the graph, as I would say. So we have, there's a 2, comma 0, there's 1, comma 4, there's 0, comma 2, and then there's -1, comma 0. If it's off by a little bit, I mean, it's a sketch, so, it's not meant to be perfect, but if you do plug in enough values, eventually you'll get the exact same thing, which, let's see, if I go ahead and let's see, here's the graph of that equation. So notice that, our sketch doesn't it looks a little rough. However, this sketch compared to that, it's not too bad. I mean, it has that the end behavior is going from minus infinity to infinity, I'm sorry, rises to the left and then falls to the right. And then we have our max right there. Let me see if I can write on this. I have my max right here, and then I have my min right there. I have that there's a point of inflection right there, and that, yeah, that keeps going, and that keeps going. So here I just used where I just used my calculator to figure out the graph and I checked it. So you can kind of see that. And then notice that right here you also have that x-intercept right there at 2 comma 0. But if you would have factored, you would have found it anyways. Okay, so that's the graph. Now, what you can probably do on your own, for instance, is basically try. Okay, so try the following equations. Y equals x to the fifth power minus x cubed, 5x cubed. And then try y equals to 4x divided by x squared plus 4. Now, interestingly enough, with this graph right here, I can already tell that this graph goes to 0 and that it's an odd function. So what that means is that your sketch of that graph should look something, let's see, that sketch of that graph should look something like where you have that it goes like this, and then it comes back up, and then it goes like that. And that's just by kind of looking at it that I can see that this goes to 0 and it's odd. So in this case, I can see that there's going to be an absolute max and that there's an absolute min. But I recommend that you just go ahead and do these problems just by using the first derivative and second derivative.